Hi, Tom Murphy, electronics teacher here at YKI High School. Just here to introduce you to some of our fantastic electronics gadgets and get you started on your first electronics course. Now, for those of you who are new to electronics, I don't want you to be worried. This is some gear and some gadgets that I'm going to show you that we've worked with third graders and everything. Anyhow, as you see, we have a little bit of fun with electronics here at YKI High School, and there's no reason why you can't as well. Let's start by looking at your letry robot kit. I've started by placing the components from lessons 2 and 3 out along the pictures on pages 6 and 7 in your letry manual. Now, we're going to be using these in the later lessons, and we're going to start off with resistors. Today we'll be doing the project in your letry handbook on pages 10 and 11, so go ahead and get that out now. For those of you new to electronics, here's some of the formulas that will help you calculate which components you're going to use when you create your own circuits. Shown here are some of the many resistors that come in your letry kit. First thing that we're going to learn is how to figure out which resistor is which, and we do that just by following the simple color code. Now you can find those resistor color codes in your book on page 5, or you're lucky because I went and also posted a color chart, which I use in my classroom here at YKI High School. Now, the color chart shows right here, black is the number 0, 1 is brown, 2 is red, 3 is orange, and you go all the way through until you get to 9, and that's white. Now, if you take a look, you have a number of stripes on your resistors. That first stripe is going to give you a digit. The second stripe is going to give you an additional digit, and then that third stripe is going to tell you how many zeros you're going to add. So let's go ahead and look at an example. In your book, it's going to require two resistors, a 300 ohm and a 10,000 ohm. Now those look like very different numbers, but they do this one on purpose. It's kind of tricky. If you look on your resistor page on page 5, you'll see the breakdown. Now let's pause just for a second here. The number 3, that's the color for orange, so we're looking for an orange stripe first. 0, that's for black, so we're looking for orange, black, and then our multiplier 300 just has one extra 0 on there, so we're looking for orange, black, brown, and that's our 300. For our 10K, well, we look, our first number is a 1, so that's a brown. Second number is black. Is 0, which is the color black, and we've looked at our multiplier. We've got 3 extra zeros there, so that's going to be an orange for a band of brown, black, orange, and then final band on all of these is going to be gold, and that really is just telling you the quality of your resistor. So with that gold band, just put it all the way over to the right, and then you'll be able to figure out which side's which. You can take a couple seconds and try to calculate some of the values of some of your other resistors, but I'm just going to go ahead and build a board, and you'll see my completed board next. Now, all that I did is I followed the schematic that you see right on your project page on page 11. And if you see, I have my red and my blue jumper wires. Here's a view right above the page right there, and I just have everything plugged in, making sure that my LEDs are the right polarity and just following the long and the short legs, making sure that everything's got power, and then making sure my batteries are installed, plug power under the board, and then you're going to notice something about the lights, and here I turn the lights off. What do you notice happens? So the less resistance means it's more electricity goes through, a brighter light. A lot of resistance on your 10K, and you get nice dim light. So here we have your first completed project. If you can take a look at the brightness of these two different lights, I think you'll be able to answer what resistors do within your circuit.